Hello everyone, today our group will present Cleveland Wastewater Treatment Plant, and this is our group names. This is our outlines for the presentations. The first thing we'll talk about introductions, and the following is the wastewater treatment process. And then we'll talk about challenges and opportunities, and the emerging problems. And finally, we'll talk about the conclusions, acknowledgement, and the references.
Okay, this is the site. On my right is the aerial shot of the wastewater treatment plant in Cleveland, and on my left is the schematic diagram of the Cleveland wastewater treatment plant. Okay, Cleveland wastewater treatment plant was established in 1998, and the site where the wastewater was located was surrounded by industries and number of local communities. And as compared to other conventional wastewater treatment plant, Cleveland wastewater treatment plant is an advanced wastewater treatment plant. In 2003, they incorporated a biological nutrient remover with an activated sludge unit. Okay, the source water is taken from both domestic and industrial wastewater. However, recently they're taking more domestic wastewater than the industrial wastewater. And the characteristics of the wastewater is like it's gray to blackish in color. Okay, the biological nutrient remover. The discharge treats the discharge, and the objective of treating the discharge was to reduce the nutrients present in the wastewater. So the objective was to reduce it from less than 5 milligram per liter to for nitrogen, and less than 1 milligram per liter for phosphorus. They have achieved the goals by less than 1.5 milligram per liter in nitrogen and less than 0.3 in phosphorus concentration, and was recorded as the best sewage treatment facility in Australia, one of the best.
And basically, the water treatment process includes 4 major steps. The first thing is the screen, and then the primary treatment, and the secondary treatment. The final is the tertiary treatment. This is basically the screenshot for the whole treatment process. And well, it's really obvious to say there's 4 main steps on the screens. And the first thing is the screen, and the screen is based on removing some large particles from the waste, and the photo is basically the machine which they're using to screen the large particles. And the second is the primary treatment. The primary treatment has the 3 major parts. The first thing is they're normally using for separate the organic matters from the wastewater, and they're often used by putting the wastewater into large sedimentation tanks, and the removal sludge will be sunk at the bottom of the tank. And the following photos showing basically the machine which they are using for primary treatment. And then I will talk about the secondary treatment. The basic secondary treatment is a biological process, and they often encourage the bacteria to degrade the sludge from the wastewater. And in general, this treatment step will be placed at the rectangular sedimentation tanks, and which is showing in the below photos. And that is basically what the rectangular tank shows. And this is basically the videos, and basically the videos which I have shot from a treatment plant.
So here we have the secondary clarifiers. What it does, as the name says, it settles down. If you look in the middle, you see it's like a brown murky water that settles to the bottom, scraped off. settle down, you could take the top off the canvas. That's basically what it was. These bridges just move around, scrape it, and you pump it back into the.
And I'll talk about tertiary treatment. The tertiary treatment is often used for disinfecting the water in this process, and they normally use chlorine to disinfect the waste source during this treatment. And this treatment steps will help to remove some specific pollutants in the waste-waters. And the following diagram shows basically what the tools the plant have been using for treating the wastewater in this process. And this is basically what have taken videos for this plant of the tertiary treatment. And after all this treatment, they definitely have some residues left. The residues remains in this process, and the residues will be collected in the large bins and transported to landfill site. And the photos, the green bins shows where the residues had been collected on the site. And they definitely have some challenges on the opportunities for the plant. The challenges there's the 5 main list challenges which our group have been decided for this plant. The first thing is the control of the BOD. The second thing is about the corrosion on the piping system, and then is the optimizations of the bioreactors, and then with the cost of the maintenance, and also is the extreme weather and the climatic events. And the photo shows basically the corrosion of the pipes on the site. And there's some opportunities as well remains on the site, and it happens on the constructions, and also happens on the landscaping, and also used for the irrigations, and there also is opportunity for industry purpose to developing more jobs for the locals. And after our group have discussed the challenge opportunities, there are some emerging problems remains on the plant. And our group has concluded 3 major points which we have thought might be the emerging problem on the plant. The first thing is about the untold weather events that might arise, and they will affect the wastewater treatment plant. And there's examples on this statement. Well, if this is extremely dry periods or dry weathers, this condition might restrict the water usage, and it will lead to the water into low-income wasting water in this treatment plant. And the second thing is the current problems. The encountered are runoffs into the main source wastewater, such as oil waste from roadside or other biological or chemical waste from the roads, industries, and the homes during the raining periods. And the third is about the sulfur deposits into the pipes can be easily oxidized by the specific bacteria to produce the sulfuric and acid gas, which can interact with the pipes materials and get corroded.
Okay, that's basically what we had from my colleague, and this slides on Cleveland wastewater treatment plant. Like we've mentioned earlier on, it's an advanced wastewater treatment plant with the addition of an extra unit, which is the biological nutrient remover. And we have seen the results that were presented. And the design itself was specifically designed to, the plant itself was specifically designed to suit the type of source wastewater, which include the industrial and domestic wastewaters. And we have also had about the characteristics of the incoming source water, which is a grayish to blackish in color. And the addition of the extra treatment unit that we've discussed, it caters for the nutrients for the discharged wastewater, the effluents. So that was achieved, and the results have been presented, and we've had and seen earlier on. Okay, the challenges, there are enormous challenges, but those challenges are met, as we've had from my colleague, which are control, POD, corrosions, optimization of bioreactors, maintenance of the treatment plant itself, and the constituents of wastewater, and the climatic events, extreme climatic events. One of the imagined problem that we have had and discussed is the sulfur deposition inside the pipes, which led to corrosion, and it has been annually been looked into and treated. So these are one of the many emerging problems that we've observed. Okay, I would like to acknowledge these people, Cleveland Wastewater Treatment Duty staff, for taking us around and explaining how the process works. And also the Griffith University School of Environment for using the room and the facility to present this video. And these are the following references that we actually obtained to produce this video.
And thank you for your guys listening, and hope you enjoy our videos.